So this talk is called Mathematical Modelling Applied to Einstein's Relativity. Right, moving goalposts happens in all of science to some extent, not just in Einstein's relativity. I've done a lot of videos explaining the moving goalposts going on in Einstein's relativity. Now, the method to move goalposts is mathematical modelling. We just deal here with it applied to Einstein's special relativity, although it gets applied to lots of science. What is mathematical modelling? While there is no consensus yet as to a precise definition of this term, mathematical modelling is generally understood as the process of applying mathematics to a real-world problem with the view of understanding the latter. One can argue that mathematical modelling is the same as applying mathematics, where we also start with a real-world problem. We apply the necessary mathematics, but after having found the solution, we no longer think about the initial problem except perhaps to check if our answer makes sense. So this is mathematical modelling, applying mathematics to a problem and coming up with a solution. This diagram shows the mathematical modelling process. Starting from the left hand side, a real world problem, you move into the mathematical world where you set up a mathematical problem and you then make an assumption, and then you go on to the next bit where you identify, construct mathematical models, and those involve equations, graphs and so forth. You then interpret the solutions, the results with data, and you apply that back to the real world solution. And the process is going round in a loop, so from the real world solution you look back to the real world problem, and then if you don't think it fits properly you go around again in the cycle. You go on to the mathematical problem again and make another assumption or modify assumptions you've got, and then carry on to work out more mathematics. So the whole process is a big loop. So the right hand side has a box called make assumption, and that is what Einstein does in his 1905 special relativity paper, but the assumptions are so vague they can be amended, adjusted. Thus, when you're in the special relativity modelling process, mathematical modelling process, it just loops around forever and there's no escape. You can just keep modifying the assumptions which are supposed to be special relativity. Now, Einstein states his postulates or assumptions in his 1905 special relativity paper, where he says we will raise this conjecture, the purport of which will hereafter be called the principle of relativity, to the status of a postulate, and also introduce another postulate which is only apparently irreconcilable with the former, namely that light is always propagated in empty space with a definite velocity c, which is independent of the state of motion of the emitting body. And with this and the subsequent things he says, he is just vague as to what that means, and I've dealt with that in other videos. Relativity principle and its vagueness is dealt with in my video entitled Relativity Principle Does Not Make Sense, while Rolf in his paper Two Myths About Special Relativity points out that whatever is supposed to be meant by a constancy of the speed of light has changed over time, i.e. its vague idea and it's changed its meaning over the years. Being vague, they are thus easily amended and adjusted. So going back to the mathematical modelling process, the input is into the make assumptions, and Einstein is then input into that box vague assumptions, which can be adjusted and changed to make the loop go on around and around forever. This diagram highlights the mathematical modelling process as a loop. More apparent, it's just going around in circles all the time. Pose the problem, mathematics, by making assumptions and considering the variables, build a mathematical model solution, analyze and interpret the solution, and so on. Each stage you just keep going round and round in circles. So there's no point in saying things like special relativity has no preferred frame, because if the model doesn't have a preferred frame and the model needs a preferred frame, then the model gets updated and the preferred frame added. And you should see my video, relativity principle does not make sense. Special relativity just keeps being updated in the mathematical modelling loop, and if you don't realise that is what's happening, then you're wasting your time. Take as another example, some people say special relativity doesn't deal with the Sanac experiment. What happens next is excuses are made about acceleration, etc., and the mathematical model just gets updated. So the philosophy of science, of how science is done, has been influenced by several philosophers. The main one is Popper. This is Karl Popper. He's generally regarded as one of the greatest philosophers of science of the 20th century. So what Karl Popper has is a philosophical theory of dealing with scientific theories, and from his proposal he's trying to talk about falsifying scientific theories. But in the end, if you find a problem with a scientific theory from its mathematics and so forth, it's just going around in the mathematical modelling cycle. So a problem with a scientific theory, then you just move its goalpost, or you just update the theory, and that's what the mathematical modelling process does. So this is the definition of move the goalposts, and it's to alter things to fit a situation in such a way as to suit one's needs or objectives. So going around in the mathematical modelling process, if you find your mathematical modelling doesn't quite fit reality, then you just make adjustments. And I have a picture here of the goalpost with wheels on it, so you can move the goalpost quite easily. So in the case of special relativity, what's happening is it's mathematical modelling going on. The goalposts get moved as you go around the mathematical model, and that means changing the assumptions that Einstein gave. The assumptions Einstein gave, which are the principle of relativity and the constancy of the speed of light, well, they're vague, they're vaguely stated, and so you adjust them to be whatever you want them to be, to try to get the mathematical model to fit. And of course the physicists don't really appreciate that that's what they're doing. They're just moving goalposts. That's the end. Thank you. The end.